Hey everybody, and welcome back to the shop. Today we'll be getting started on section 7 of the RV10, which is the rudder. Just like with the vertical stabilizer, the first thing Vans has us doing is cutting some partially formed parts into their final dimensions. In the first couple of steps, we trim some webbing from the top and bottom ribs to separate them each into two different parts. Those parts are later joined together to form the top and bottom ribs. Next, there are 7 shear clips that are all joined together as a single piece, so we cut those apart and file them down to size. That part was actually pretty difficult to see in the old cameras, so I just left it out of the video. Speaking of old cameras, I picked up some new cameras for these recordings, 3 new cameras to be exact. They're GoPro knockoffs by a company called Akaso. I think the model number is EK7000. Anyways, they've been out for a couple of years, but they're capable of recording in 4K or 1080p at 60 frames a second, which is what I'm using here to make things look a little bit better when I speed them up. I was using Wise security cameras before, which are great little security cameras, but have some pretty significant limitations when trying to use them for full recording like I'm doing. Anyways, what I'm doing here is cutting the stiffeners that form the inner skeleton of the rudder. There are 7 pieces of angle aluminum with holes pre-drilled at specific intervals, and my job is to cut them each to length using dimensions given by Vans. The first piece is cut directly in half, and for each subsequent stiffener, a larger section is cut out of the middle. I started cutting all 7 in half using a hacksaw, and then took each to the bandsaw to refine the cut. Once cut to length, there's a section of aluminum that has to be cut from the end of each piece so that they taper towards the center bend. The result is a set of progressively shorter left and right pieces that later go together to form the ribs of the rudder. These operations where I'm cutting parts are always scary to me. Once cut, there is no going back. If I mess up a couple of rivets, I can just drill them out and try again. If I mess this up, I'm sitting and waiting for the postman to bring me a replacement part. That's just super scary to me. In the end though, I was able to trim these parts without any significant mishaps and move on. One thing worth mentioning here, for pieces like this, I never cut right on the line that I measure. Instead, I cut a little bit to the scrap side of the piece and later use a tool with finer control like the Scotch-Brite wheel to bring the edge right up to the line. It sounds kind of obvious as I'm sitting here saying it, but if it's not something you've ever heard, you might not think about it. So finally, I pull out the Scotch-Brite wheel and I clean up all of the edges to deburr and get rid of any marks left by the bandsaw that could later turn into stress risers, resulting in cracks down the line. Once all the pieces are cut and trimmed, it's time to start pre-fitting the skeleton together with clecos and match drilling. This starts with the bottom rib and the rudder cable bracket. You can sort of see the 2 pieces of the bottom rib that were cut off camera that I'm working with here, as well as the 2 pieces of the top rib sitting at the very top of the workbench. Anyway, those 2 pieces get clecoed together to form a long taper that sort of looks like the trailing edge of the rudder. Once clecoed together, I grab the number 30 drill bit and get all of the holes matched drilled. Drilling complete, I head over to the parts rack to find the R1005 rudder horn. And then I stare at the plans for what seems like an eternity, flipping forward and back in the plan book. At this point, I'm not really sure what I was confused about. The only thing I can think of is there are 4 holes that I need to machine countersink, 2 on one side and 2 on the other side. Maybe I was just trying to make sure I knew exactly which holes I was working with, though the plans are super clear. There are literally arrows pointing at the holes with countersink this side on them. But after a few minutes of looking, I head over to the Scotch-Brite wheel to clean up the edges before countersinking and fitting the horn to the bottom rib. I've been somewhat obsessive about deburring parts based on what I've read on the Vans Air Force forums. I'm not sure if I'm overdoing it, so if anybody knows better than me, please chime in the comments. After a little bit of filing in the areas I couldn't get to with the Scotch-Brite wheel, and then cleaning up the corners with the deburring tool, I'm finally ready to drill and countersink the 4 holes of the rudder horn specified in the plans. The 2 top holes that you countersink on the aft side of the rudder horn match holes that you later countersink in the rudder striker plates. This seemed confusing to me that both sides of a single rivet were countersunk, but the plans later call out that this is to keep the material thickness within the grip range of the rivets that are used. Once done, I cleco and clamp the rudder horn to the bottom rib and match drill the 6 holes from the top of the rudder horn through to the rib with a number 30 drill. There are no pre-punched holes in the rib for this step, so it's important to take your time, though the rudder horn acts as a good guide to get it right. The plans also call out the importance of the rib being straight along its length, so I grab a straight edge and lay it along the flange to make sure it hasn't been bowed while working with it or during the shipping. Those holes drilled and clecoed, I can remove the clecos from the forward side of the rudder horn as well as the clamp, and we are done test fitting this and can start test fitting it to the forward spar. After a bit of searching, I find the forward rudder spar, and just like always, the first step is cleaning up the edges and the lightning holes. I've thought about removing this kind of stuff from future videos, since if you've seen it done once, you've seen it all, but I haven't decided yet. My main goal with this channel was to document my build for the FAA, but a secondary goal was to show exactly what building this aircraft is like from start to finish. I feel like cutting out the quote boring parts from the video is a bit counter to that goal. But let me know what you think in the comments. I keep all the raw footage, so making changes to the channel to make it more enjoyable for you guys is definitely possible. The observant among you will notice that the blue protective coating has magically reappeared on the spar. I accidentally pieced together the video clips in the wrong order and didn't notice until I was recording the voiceover. This is actually one of the downsides of these new cameras. When you take the battery out of them for even a short time, they lose their settings, including the time. So when I changed over the batteries, the created timestamps on the video files got all messed up. This made editing the video pretty difficult as I had to figure out where the videos were supposed to go without using file information and timestamps. I actually recorded most of this work a couple of weeks ago, but the editing in VoiceOver took forever, partially because of this problem. I think you guys get the idea though. I did the lightning holes first, removed the blue film, and then cleaned up the edges using the file and then the deburring wheel. For the final steps of the rudder skeleton, the stiffeners that I cut at the beginning of the video are clecoed to the shear clips and match drilled to form the middle ribs. They come to a taper much like the bottom rib does. I then clecoed those to the rudder spar, completing the rudder skeleton. Unfortunately, I lost all of that footage when the batteries on the cameras died, I hope you're enjoying riding along on this journey with me. If so, do me a favor and click that thumbs up button and let me know. Leave your comments and suggestions below, and until next time, build on.